The next pattern I'd like to talk about is the prototype pattern. Now, why would we need a prototype pattern? Essentially, our app needs copies of objects. The objects may not have simple value types or properties. They may, in fact, have other objects that are properties, and those objects might include properties that are of other object types. So we can get complex objects that we need copies of for our application. For example, we might have a user object that we want to pass around from page to page or screen to screen in an application. Now, at the top level, the user object might have a name, a username, and password properties, and those are easy to copy. But then it may further have an address object property, or addresses, perhaps one for home and one for business. And then it might have an account property as well, or accounts. For instance, if we had credit card accounts associated with that user. So we can get deeper and deeper into the user object, and it makes the copy process more and more complex. Much like the builder pattern, we want to isolate all of that code from our application. We don't want to repeat all of this copy code that dives into objects and copies every property of objects and all that all over the place in our code. So the definition of a prototype pattern by the Gang of Four is to specify the kind of objects to create using a prototypical instance and create new objects by copying this prototype. So essentially what we're saying is we want to create a single object and an instance of that single object, and then create the new objects just by copying that, using it as a prototype or a template. In our implementation, we want to provide a method on the object to copy itself. In .NET, we use the iClonable interface, and the iClonable interface has a single method to it called clone, and clone will return a copy of a given object. We also have to talk about deep and shallow copies. So as an example, we want to copy a user object. So we have a user abstract class that has the name, username, and password properties. It also has some address object properties. Because we're going to make it a prototype, we're going to provide a clone method, or two, depending upon the example. In actuality, you'll probably just have one clone method. And that clone method will be the implementation of the iClonable interface. Now, the user class is an abstract class, so we want to create some instances. So our application might have administrative users, guest users, customer users, different kinds of users. So let's just talk about an admin user. We're going to create an admin-derived class, and it's going to implement the iClonable and clone method. All of the other classes would actually probably have similar implementations, but they might have different properties depending upon their capabilities. For instance, an administrator class would probably have a few extra properties compared to a guest class. So a shallow copy might use the memberwise clone method. An object has a memberwise clone method. You get that for free in .NET. And what it does is it copies the properties of the object and essentially makes a copy of it. However, it copies references to the object properties. So in our case with the user, it will copy a reference of the address, not make a deep copy, which means that if I make changes to that clone, to that copy, the changes will also go back to the original. Now, this may be what you want, but it's often not the behavior you're expecting at all. In all likelihood, you'll want to provide a deep copy for your clone method. A deep copy will copy the values of all of the properties, including the properties of sub-objects. So in our user case, it will copy the username, the name, the password, but it will also go into the address property and copy the address, city, state, and zip, and make actual copies of that, as opposed to just copying a reference of the address object. So that's a really important distinction. So although memberwise clone is easy to use and doesn't take a whole lot of code, there is that nasty side effect that can really get you into trouble. So here's what our class diagram looks like, and it really isn't a whole lot in terms of the classes. We have our user abstract class, which we have a business address object and a home address object. Then we have first name, last name, password, and username. Some very simple user objects. Then it has two methods, clone and deep clone. And you'll note that up top there, it says we're implementing the iClonable interface. Clone is the method that implements that interface. I've provided both methods, and we'll see them in the example just to show you the difference between a shallow copy and a deep copy. For practical use, you're just going to want to provide a clone method and make that choice as to whether it's going to be shallow or deep, and not create a lot of confusion by providing multiple clone choices. In terms of class design, we really just want one method to accomplish that task. Then we have our derived admin class, and it has all the same properties, and then it implements the clone and deep clone methods. And then down below, you can see the address object. Simply address 1, address 2, city, state, and zip. So that's the pattern, and of course the really important detail is actually in the clone method. So we'll be taking a look at the details of that in our code example.